Hey there guys, so in this video, me and my friends will do a quick tutorial about Splay tree data structure. Let's not waste any time, let's get into it. So what is Splay tree? Splay tree is a self-adjusting binary search tree data structure, which means that the tree structure is adjusted dynamically based on the access or inserted elements. In other words, the tree automatically reorganizes itself so that frequently accessed or inserted elements become closer to the root node. Splay tree was first introduced by Daniel Dominic Slater and Robert Endor Tarhan in 1985. It has a simple and efficient implementation that allows it to perform search, insertion, and deletion operations in O log n amortized time complexity, where n is the number of elements in the tree. The basic idea behind splay trees is to bring the most recently accessed or inserted element to the root of the tree by performing a sequence of tree rotations called splaying. Splaying is a process of restructuring the tree by making the most recently accessed or inserted element the new root and gradually moving the remaining nodes closer to the root. Operations in splay tree. Insertion. To insert a new element into the tree, start by performing a regular binary search tree insertion. Then apply rotations to bring the newly inserted element to the root of the tree. Here's an example of insertion. So let's say we want to insert 4, node 4. So we put 4 right there. So why did we put 4 at the bottom left of 6? Let's take a look at the root, node 9. So all the lower than line will go to the left side, and all upper than line will go to the right side. So since 4 is lower than 9, we put 4 at the left side. Since 4 is still lower than 6, so we put 4 at the bottom left. That's why its machine is right there. Since we inserted the location of 4, we will do a rotation because we want 4 to be the root. So let's start by 12 by moving it, then node 9, then node 6, and then node 4. And then still node 12, node 9, node 6, and node 4. Since node 4 is the new root, what about the node 7 that left behind? So 7 will go to the bottom left of 9. That's how you insert in insertion. Let's move on to deletion. To delete an element from the tree, first locate it using a binary search tree search. Then if the element has no children, simply remove it. If it has one child, promote that child to its position in the tree. If it has two children, find the successor of the element, the smallest element in its right subtree. Swap its key with the element to be deleted, and delete the successor instead. Here's an example of deletion. Let's say we want to delete node 6. First, we will start from node 4. We will search if it's the node that we want to delete. Next, we go to node 6. Since 6 is the node that we want to delete, simply delete it. And its successor will be the one we promoted. So 9 will go up, and 12 will go up, and 7 connect to 9.
Search. To search for an element in the tree, start by performing a binary search tree search. If the element is found, apply rotation to bring it to the root of the tree. If it is not found, apply rotation to the last node visited in the search, which become the new root.
Here's an example. We want to search node 7. Let's start from the root. That's not what we want to search. We want to 9. Still not the one. We go on to the bottom left. We found that we want. Now we want to do a rotation. 12 will move down, so as 9, and 7 will go up. And then we'll do another rotation. 4 will go down, and 7 will go up. 9 will go up, so that was 12. Now the 7 is the new root.
Rotation. The rotation used in Splay tree are either zig or a zigzag rotation. A zig rotation is used to bring a node to the root, while a zigzag rotation is used to balance the tree after multiple access to element in the same subtree.
So here are the examples of rotations. First, we have zig rotation, zag rotation, zigzag rotation, zigzag rotation, zigzag rotation, and zag-zig rotation.
Zig rotation. The zig rotation in just single rotation. In simple term, the single to right rotation. An example, we were going to play the node 4, the root. An example, the node 6 is children, and node 4 moved to the right, and 4 node is parent, and 6 node and 7 node move 2 times to get the root, and that's how zig rotation. Zag rotation. The zag rotation in just single rotation. In simple term, the single to left rotation. An example, we were going to play the node 6, the root. An example, the node 4 is children, and node 6 moved to the left, and 6 node is parent, and 4 node and 3 node move 2 times to get the root, and that's how zag rotation.
Next rotation and split tree, the zigzag rotation. This rotation results in nodes shifting to position to the right from their current location. Note the example. We're going to split the node 3. Node 3 here guys is our leaf. By the way, the leaf is the bottommost children. The root here is the node 6, the children are the node 7 and the node 4. The node 4 is also the parent of the node 5 and node 3. In this rotation, we need to put the leaf after the root. The location of the node 3 is 2 nodes from the root. We all know that the zig rotation is to move to the right from their current location. In zigzag rotation, we need to move the node double to the right rotation in order the left to move up to the root, and that's how the rotation of zigzag works. Next rotation and split tree, the zigzag rotation. In zigzag rotation, of course, it's just a double zag rotation. In simple term, double to the left. In the example, we're going to split the node 7. The root in this example is the node 4, the children are the node 3 and node 6. And the node 6 is also the parent of node 5 and node 7. From the left, we need to move the node 7 to the left 2 times to get to the root, and that's how the rotation of zigzag works. Next rotation and split tree, the zigzag rotation, is just simply the combination of zig and zag rotation. Means go to the right, then go to the left. Look at the example, we're going to split the node 5. In the example, our root is the node 4, the children are the node 3 and the node 6. The node 6 is also the parent of the node 5 and node 7. First, the node 5 rotate to the right, then the node 5 become the parent of the node 6, then the node 7 still gonna be the child of the node 6. Then the node 5 rotate to the left, and finally he's gonna become the root. And that's how the zigzag rotation works. The next and the last rotation and split tree, the zigzag rotation. In zigzag rotation is just a combination of two rotation, the zag and the zag rotation. It means move to the left, then move to the right. In the example, we need to split the node 5. The node 6 here is the root, the children are the node 7 and the node 4. The node 4 is also the parent of the node 3 and node 5. In this rotation, just move the node 5 to the left, and then his parent is gonna become his child, but the other child of the node 4 is still his child. Then the node 5 move to the right, and then the node 5 is finally gonna become the root. And that's how the zigzag rotation works.
And that will be all in our tutorial video about Splay tree. I hope you learned something in our video. Thanks for watching. Peace.